Okay, so we already know two forms now of quadratics. We've got standard form, which looks like this. We've got vertex form, which looks like this. And we've talked about how to graph the parabola in both. Here's just some summary. You can look through this on your own, but this is some stuff we already know. The thing I want to point out is this is what we know about each form. The thing I want to point out is when you're graphing, the first thing you must do is find the vertex, always. So in standard form, we learned that we find the x value by negative b over 2a. Then this means plug it in, plug that x in to find y of the vertex. Right? Anytime we have the x of any point, not only the vertex, we can plug it in to find its corresponding y coordinate. Vertex form is nice because we can pull the vertex right out. Okay, we know that this one, the h, is going to be the opposite, but it's easy to find the vertex in vertex form. So that's the first step, is we always want to find the vertex when graphing first. Okay, so now we have a third form we're going to look at called factored form. And before we get into factored form, we're going to look at that zero product property again. So remember that in math, factors are things that are multiplied. In multiplication, two things multiplied is called a product. Like A times B is a product. And we know from the video our zero product property, which is going to be crucial here. What we know about the zero product property says that if two products, that means two things multiplied together, equal 0, then the first one has to be 0 or the other one has to be 0. So either one of the products needs to be 0, one or the other. So whenever I have two products, that means I have potentially two solutions to this entire equation. If I had three products, then I have potentially three solutions when A is 0 or when B is 0 or when C is 0. So here we go. We've got a zero product property going on here. Why is it product? Because this is multiplication between each thing. So I've got my first factor, my second factor, and my third factor. And when I multiply factors, we call it a product. Okay, so there's my three factors. So I have three potential solutions. So if the first factor equals 0, that provides a solution. Well, 2 is 2. 2 could never be 0. There's no x in there. There's no room for variance. So no solutions come from that first factor. If I take the second factor, a solution could come from there when that factor equals 0. So I subtract 4 from both sides and I get a solution there. If x plus 4 equals 0, then the whole thing by the zero product property equals 0, which is what we're trying to show. We're trying to show this whole side equals 0, or try to find x's that make that happen. Negative 4 is one of them, because if I plug negative 4 in, it makes this factor 0, and then zero product property says everything else has to equal 0. The whole thing has to equal 0 if that product is 0. There is a third product, or a third factor. So if I set that third factor equal to 0, I add 6 to both sides, I get my solution there. That means if I plug a 6 in for x here, I get 0 for this factor. The whole thing has to equal 0. So let me just show you these solutions by plugging them back in. It is important to note, we don't plug them in at the same time. It's one or the other. Let's say we go with the first one, x equals negative 4. I have to plug negative 4 in for each x everywhere. So then I end up getting 2 times this part is 0 and this part is negative 10. So that makes it a true statement when I plug in negative 4, because this is 0, and by the zero product property, this whole side then has to be 0. So it's a true statement. The other solution, x equals 6, if I plug that in for x in both spots, that's also a solution, because I get 2 times 10 times 0, and since this factor is 0, the zero product property says that this whole product, if I multiply all that together, will equal 0, and that's a true statement. That's why those two are solutions. Now we have a quadratic written in what I'll call factored form. So this is our third type of form. This is going to be a parabola, because I know that if I multiply everything out, the highest power of x will be x squared. I could sort of look into the future. And a will be 2, by the way. Right? So that a is still our a. That's the same A and everything else. It tells us the shape of the parabola. It tells us which way the parabola opens. Still the same A. So now we've got factored form. We want to find the x-intercepts. We plug 0 in for y. And since it's factored, the zero product property is what we're going to use here. We know the whole right side equals 0 when each factor equals 0. So when 2 equals 0, or when x plus 4 equals 0, or when x minus 6 equals 0. This doesn't have an x in it, so it's never going to be 0. It's always 2. This one could be 0 when x is negative 4, that factor. And this factor could be 0 when x equals 6. Now we want to find that this is finding the x-intercepts, because remember we plugged in 0 for y. So these are the x's. We know the y coordinate to be 0. So there are our x-intercepts. Now let's look at how to graph when it's in factored form. So again, this is our basic version for factored form. And what we know based on this, by the way, what we found out here is that whatever these constants are in the factors, then if it's written in this form, then the opposite is the x-intercept, right? We know if it's x plus 4, then negative 4 is the x-coordinate. Negative 4 is 0. And if it's x minus 6, then it's 6. So that's what this says right here. In factored form, if I have x minus, I'm going to write this a little differently. If x minus b times x minus c, if we have that, then we know that the x-intercepts are b0 and c0. All right, so here's an example. Which way does it open? It opens up because a is bigger than 0. Our a is 3. Is it narrow, wide, or normal? It's narrow because the absolute value of a is bigger than 1. X-intercepts, well, we know that we plug in 0 for y. And the zero product, since it's already factored, the zero product property would tell us that when x minus 4 equals 0 and x minus 10 equals 0 will be solutions. So we get x equals 4 and x equals 10. So my x-intercepts are 4, 0, and 10, 0. And again, we know that now that when it's in factored form, it's going to be the opposite of these guys. So we see an x minus 4 and an x minus 10. So it's going to be 4 and 10. The axis of symmetry. So here's the new one, because we do want to find the vertex if we're going to graph this thing. So whatever your x-intercepts are, 4, 0, 10, 0, the axis of symmetry is always going to run through the middle of those, because these are symmetric points. Your x-intercepts will always be symmetric. Why is that? Because they're both always going to have the same y value, which makes them the symmetric points. So the axis of symmetry is always going to be running right through the middle of those. So my axis of symmetry is x equals 7, because it is the average of the x-intercepts. So we've got 4, 0, and 10, 0. So let's look at this thing. There's an x-intercept, and there's an x-intercept. So I know the axis of symmetry has to run right between them, because it has to be symmetrical in a parabola. So what I do is I average those. If that's at 4 and that's at 10, then this has to be at 7. 10 plus 4 is 14. Divided by 2 is 7. So my vertex always has the same x as my axis of symmetry, and then I have to plug it in for x. So I got 3 times 7 minus 4 times, and it was x minus 10, right? 7 minus 10. So I get y equals 3 times negative 3. So it's going to be y equals negative 27. So our vertex is 7, negative 27. I'm going to have to go by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So there's 30. So 27 is right here. So then I have my 3 points. Whoops, I made that 2v-ish. There's my parabola. That was at 7, negative 27. That's my vertex. I've got 3 points, so I can graph it. My y-intercept, I got to plug in 0 for x. So now we have y equals 3 times 0 minus 4 times 0 minus 10. So I get 3 times negative 4 times negative 10. Y equals positive 120, which is off our graph, so we're not going to have to graph that. The y-intercept is 0, 120. The symmetric point will be something 120. So let's see. If my x-intercept is 0 and my axis of symmetry is at 7, that means it's going to be 14, 120. So we don't need to graph those because we don't have enough room. Our domain is always all real numbers. Our range is going to be y is bigger than or equal to, because my parabola opens upward. So it's going to be all the y's, right? If I look across here, all the y's that are bigger than, so we're going in this direction, right? All these y's. And that is at what? Negative 27. These are all negatives. At negative 27 or higher. So y is going to be bigger than or equal to negative 27. Transform the quadratic into standard form. So now we have y equals 3 times x minus 4 times x minus 10. The way you make it, turn it into standard form, is you multiply. So I'm going to leave this 3 out front, and I'm going to multiply the binomials together. So I distribute x times x is x squared. X times negative 10 is negative 10x. I'm done distributing that. Now I can distribute my negative 4. Negative 4 times x is negative 4x. Negative 4 times 10 is 40. So I have plus 40. Now I can multiply out, oh no, I want to combine like terms. So I get negative 14x plus 40. So I combine like terms. Now I'm going to distribute the 3 to everything. So I get 3x squared minus 14 times 3 is going to be 45 minus 3, so 42x plus 120. Don't need parentheses. That is now in standard form. Now we want to write it in vertex form. Well, we know A is 3. We know the vertex is 7 and negative 27. I'll just write that here for reference. So the x, I always do the opposite. And then minus 27 stays the same. So now we have 3 forms. We have factored form, vertex form, and standard form.